Hi! Welcome back to our class Chemistry 100B. Today, I'm going to discuss the solutions to the problems which I gave you in your exercise number 3. For next meeting, kindly be prepared for a quiz about measurements on fundamental quantities and derived quantities. Problem number 1. The mass of a tablespoon of sugar is 200 grams. Express this mass in terms of milligram, microgram, and ounces. For problem number 1, it gives us that the mass of the tablespoon of sugar is 200 grams. And we are asked to express this in terms of milligrams, microgram, and ounces. So to convert the mass, which is 200 grams, to milligrams, you have to multiply 200 grams by 1,000 milligram per gram. So you can cancel out the gram unit, leaving the milligram unit. So the answer is 200,000 milligrams. Expressing this in terms of its scientific notation, it is 2 times 10 to the positive 5 milligrams. For letter B, we are asked to express it in terms of microgram. So the 200 grams of the table sugar times 1 million microgram per gram. So you can cancel out the gram unit, leaving the microgram unit. So the answer is 200 million micrograms. Or expressing it in terms of its scientific notation, it is 2 times 10 to the positive 8 micrograms. In letter C, we're going to convert the 200 grams to ounces. So we have the 200 grams of table sugar times 1 pound per 454 grams times 16 ounces per pound. So we have the answer 3,200 divided by 454, and the final answer is 7.05 ounces. Number 2. The diagonal of the face of a square measures 25 millimeters. Find the area of the square. In problem number 2, we are given here that the diagonal of the face of the square is 25 millimeters. And we are asked to get the area of the square. Since the side of the square is not given, we have to solve it by applying the ratio proportion using the 45-45 degree triangle. If you are going to use the ratio proportion, we know that in a 45-45 degree triangle, the sides are 1, 1, and the hypotenuse is square root of 2. So the ratio will be x is to 25 equals 1 is to square root of 2. So cross multiplying, you have square root of 2 times x equals 25. So x equals 25 divided by square root of 2. And the answer is 17.86 millimeters. Now this measures the side of the square. Since we are asked to get the area of the square, we substitute this value of 17.86 millimeters to A equals S squared. So we have area of the square equals 17.86 millimeters squared. So the final answer is the area of the square is 318.98 millimeters squared. Problem number 3. The 5 peso coin has a diameter of 1.25 inches. What is the area of the coin? In number 3, we are given that the diameter of the 5 peso coin is 1.25 inches. And we are asked of the area of the coin. Now, using the formula in finding the area of a circle, where it is area of the circle equals pi r squared. Since we are given here that the diameter is 1.25 centimeters, we have to divide this diameter into 2 to get the radius, since we know that the radius is half the diameter. So to substitute this to the formula pi r squared, so the area of the coin equals 3.1416 times 0.625 squared equals 3.1416 times 0.391, and the final answer as the area of the coin is 1.23 inches squared. Problem number 4. A grain of table salt has an average area of its face which is 25 square micrometer. Determine the volume of the grain of table salt. Problem number 4. We are given here that the average area of the face of the grain of table salt is 25 square micrometer. And we are asked to get the volume of the table salt. Now, since the side of the cubic table salt is not given, then solve it first using the area of the face of the table salt. Using the formula area equals S squared, then substitute the value of the area of the face of the square, which is 25 micrometer square, equals S squared. So S equals the square root of 25 micrometer square. So S equals 5 micrometers. This S represents the side of a cubical grain of table salt. Then substitute this value of S, which is 5 micrometer, to the formula in solving for a cube, which is volume of a cube equals S cubed. So you have 5 times 5 times 5. So you have 5 cubed. So 5 cubed is 125 micrometers cubed. Problem number 5. Determine the volume of a dice with a diagonal on its face which is 1.2 centimeters. Problem number 5. We are given in the problem that the diagonal of the face of the cube is 1.2 centimeters. And we are required to get the volume of this cube. Since we are given the diagonal and we are not given the side, so you have to solve first the side of the cube. Using the ratio and proportion, with a 45-45 degree triangle. We know that in a 45-45 degree triangle, the sides measure 1, 1, and the hypotenuse is square root of 2. So using the ratio proportion, we can have the equation x is to 1.2 as 1 is to square root of 2. So cross multiply, you will have square root of 2x equals 1.2. So x equals 1.2 over square root of 2. So the answer is 0.849 centimeters. So we get the side of the cube to be 0.849 centimeters. With this measurement of the side of the cube, we are going to substitute this to the formula in finding the volume of a cube, which is volume equals S cubed. So you have volume equals 0.849 centimeters cubed, and the answer is volume of the cube equals 0.612 cubic centimeters. Problem number 6. A cylindrical iron rod has a circumference of 1.5 centimeters and a height of 12 centimeters. Find the volume of the cylindrical rod. In problem number 6, we are given that the circumference of the iron rod is 1.5 centimeters and the height is 12 centimeters. We are asked to get the volume of the rod. Now, since this is a cylindrical rod, the volume is governed by the formula pi r squared h, where the h here is the height of the metal rod. Since the radius is not given, so we have to solve for the radius. Using the formula, circumference equals pi d, or C equals pi d. Solve first for d, where d is the diameter of the circular base of the rod. So d equals circumference over pi. Substitute the circumference of the metal rod, which is 1.5, divided by the value of pi, which is 3.1416. So the diameter measures 0.477 centimeters. Now, radius is half that of the diameter. So divide 0.477 by 2. So the radius is 0.24 centimeters. Substitute this value of the radius to the formula in finding the cylinder or the cylindrical metal rod, which is volume equals pi r squared h. So you have volume equals 3.1416 times 0.24 centimeters times 1.5 centimeters. So the volume is 1.1 cubic centimeters. Number 7. A lady wants to know the density of her ring. If the ring has a mass of 12 grams, and when placed into a beaker of water, it displaces the water from 20 ml to 28 ml, what is the density of the ring? We're given here that the mass of the ring is 12 grams and the initial volume reading of the liquid level is 20 ml, while the final volume reading is 28 ml. We are asked of the density of the ring. We said that density equals mass over volume. In this case, the ring is an irregularly shaped object. So we are going to avail of the Archimedes principle which says that the volume of a liquid displaced when an object is placed totally into this liquid is equal to the volume of the object. So get the volume of the object by getting the difference between the final volume reading and the initial volume reading of the liquid. So in this case, we have 28 minus 20 equals 8 ml. So substitute that volume to the formula density equals mass over volume. So 12 divided by 8 equals 1.5 grams per ml. Or expressing the volume in terms of cubic centimeters, we know that 1 ml is approximately equal to 1 cc or 1 cubic centimeters. So the density of the ring is 1.5 grams per cubic centimeters. Number 8. How many calories of heat is needed to change the temperature of a 10-gram ethyl alcohol from 28 degrees centigrade to 30 degrees centigrade if the specific heat of ethyl alcohol is 2,440 calories per gram per degree centigrade? In problem number 8, we are given here that the specific heat of ethyl alcohol is 2,440 calories per gram per degree centigrade. Now we are asked of the amount of calories which is needed to change the temperature of 10 grams of ethyl alcohol from 28 degrees centigrade to 30 degrees centigrade. So since we are asked of the number of calories of heat, the formula to be used is Q equals mc delta T, where Q here is the required number of calories of heat. So substitute the values given to the formula. You have 10 grams times 2,440 calories per gram per degree centigrade times 30 minus 28. So your answer is 48,800 calories of heat. Or, if you express this in terms of its scientific notation, you have 4.88 times 10 to the positive 4 calories of heat. That would be all for today. This is your teacher, Professor Nisitas Ruiz of Holy Name University.